Hello, welcome to the keynote presentation for the CONF-SPML 2024. I'm Stavros Shiaeles and I'm an associate professor in cybersecurity at the University of Portsmouth in UK. The keynote today will be collaborative intrusion detection system using blockchain technology. So a quick outline of the presentation today is we're going to have an introduction, the motivations behind this work, background information, proposed solutions, experimental results we did with this work, conclusions that they came out of this work, and finally some questions. So, what are the objectives of this research? First of all, is to study. We need to study the previous research that is happening on the snort and collaborative intrusion detection systems with the Hyperledger Fabric technology, blockchain technology. The other objective is to implement a hypothetical solution with a proof of concept with the snort and Hyperledger Fabric. So we want to uh, connect these two, Snort, which is an intrusion detection system, network intrusion detection system, and see if we can create a collaborative network through the blockchain technology, and to evaluate and recommend the research gaps of the future works. So currently in this picture, you can see the key cybersecurity trends. As you can see here, we have a lot of phishing. Is the top one. The phishing, you can see most cyber attacks in companies that come from phishing. We have the second one, which is network intrusion. We have disclosure of information, lost device or USBs, generally lost of some hardware which they have sensitive information about companies, and mm, bad system configuration. So the the systems they were not configured correctly with cybersecurity in mind. So the top global fraud types, we have phishing, we have Roach mobile app, which they install them in the application, they steal money. We have brand abuse. Someone is claiming to be uh, a brand, for example, IBM or um, some company that's selling clothes or bank. And 60% we have the Trojan horses. So infiltrating to the infrastructure using malicious software that give access remote, the attacker remote access. And by the source here, by the volume of cybersecurity incidents by sector, we have financial services, the most affected sector with 27%, ICT, manufacturing, retail, as you can see, professional services. So as you can see from the previous slide, we have a lot of issues of attacks. So the idea here is to see what can we do in order to mitigate these attacks. And we think that a collaborated intrusion detection system will be a nice solution for this problem. So blockchain. Blockchain, it's an interesting technology that it was introduced lately, the last years. All started with the cryptocurrencies, which you all well aware, and we have to say that this an emerging technology which is enable the creation of decentralized environments. The cryptography that is being used in blockchain and for the validation of the transaction and the way that this works is it make it, let's say, tamper proof. So it's interesting. The cryptography used is according to the standards that they've been used by big companies and banks. So until now, let's say, it's not been compromised. This technology, the distributed public ledger and all committed transactions are stored in chain of blocks. So we have these blocks of the transactions in the blockchain, which is like a distributed database. Let's say we have two types. We have permission and permissionless. The difference between them is permission is private blockchain. So in order to access it, you need to go through a validation process and give you access from the organization. Permissionless is public, is like Bitcoin. You just register and you have access to it, and it's perfect for transparency because all the blocks are added and this is public available so you can see them. So what's the difference between permission via permission? I already did an introduction. What is the difference? The one is open, the other one is closed. So permission blockchains, it means it is better because you control somehow who is entering this network blockchain, so you can avoid attacks like 51 attack, etc. Of course, you can avoid it, but you need to build a big network because the smaller that your network it is, the the devices that they do the validation, they are more prone to 51 attack. That means 51% of your validators are being compromised. But in order to be compromised, an attacker needs to enter this permission network, which is more difficult than the permissionless. Of course, the permissionless, because it's open and public, as you can see from the blockchain, from the Bitcoin, etc. They are bigger, they are huge networks, so it's harder, let's say, to gain the 51%. In the permission, you have a governing authority, which is act as the gatekeeper and allows access, etc., under some circumstances and some validations. This authority also is providing the trust. In permissionless is trustless, so you don't have this authority. It's only in the maths. In permission, you have consensus, which can be reached more quickly because it's limited the numbers, as I said, of user, but you have also other problems, as I said, the 51 attack and other problems. In permissionless, it takes longer because you have more nodes, more people there, so it run more complex computations. And finally, the permission is less mind share. The permissionless is more mind share. So Ethereum has 4 times more developers than any other blockchain. So you need less developers for the permission comparing to the permissionless. Now you'll be wondering why hyperledger fabric. So we went through and we analyzed all of uh, the Hyperledger Fabric um, ledgers available because they have many of them. First of all, Hyperledger Fabric project is a big project and it has many, let's say, branches, different like Sawtooth, uh, Indie, as you can see here, Iroha, Fabric. So the first thing is that is under the it's a Linux Foundation project. It's open source, so that means you have the code, you can read the code, you can do modifications, you don't have any restrictions about that. Uh, there is a big, let's say, community supporting these projects, and they gain a lot of attention and from big companies as well, like Azure, Huawei, IBM, Oracle, Alibaba, and many others, Google, etc. So it's been implemented in these providers, in this service provided. So big companies are supporting them, and they're very stable projects in order to set up your blockchain, your permission blockchain, and use it. Very good project, very interesting project. It started in 2016, so it's mature enough. 7 years, it's good for maturity, and they keep supporting and developing things on this project. So this project has many different branches. Let's say you can see them here in this area, and there is a lot of support and very interesting. So that is answering the whys, all of these why we use that. The reason is, first of all, the openness, the performance that the support up to 1000 terabits per second, TPS, transaction per second. It's mature, it's open source, it's modular, they have high availability, uh, it can support various modules, it has an API, which is very important for the collaborative intrusion detection systems to analyze malicious signatures. So all of these reasons led to use Hyperledger Fabric for our projects. The next thing is, okay, we have Hyperledger Fabric. We decide to do a proof of concept with Snort to see if we can combine these two and use them. So we need to figure out some use cases. So in this case, uh, we thought the following here, these use cases. We thought the collaborative intrusion yacht anomaly detection framework in order to achieve distributed collaborative anomaly detection for devices with limited resources. That's important. The limited resources. The second one, we have a trust-based blockchain in collaborative intrusion detection systems to safeguard the integrity of information shared among the peers. This way, we are enhancing the accountability and securing the collaboration by preventing insider attacks. The other one, it could be used is in microgrid systems. Again, we don't have a lot of resources, so using blockchain proposal is rich based on improve uh, delegate proof of stake algorithms after receiving the detection results identified based on the one class support vector machine. So we use SVM for that. And the other one is early prototype of node-based CDN with blockchain using trust node and participant nodes. This is some use cases, this system that it could be used. And here you can see the diagram. So you have the microgrid here, you have the NIDS. Here is the traffic is coming from the internet. Alerts are going here to the trust system. It's been analyzing using technologies. It could be machine learning on anything that it could be analyzed in order to minimize false positive, false negatives, etc., and also to calculate these blacklist IPs. All these black IPs list is been added, and all of this is shared to the network, the collaborative intrusion detection network with other IDSs in order to protect other systems that they don't have the attack currently. Only one system is having this attack, but by sharing this information to other systems, you can provide protection to other systems that this attack didn't go through. So there is various here the about trust calculation engine. This is a big discussion. There are various things you can do in order to measure the trust. But the idea of this, it was initially to see if it's possible to create the CIDN. This is the big picture, as you can see here. So we have host-based ideas, network-based ideas, we have alerts, we have machine learning to find what is happening. We have collaborative intrusion components here with the various algorithms, and all of this is shared through the network. So the hypothetical these use cases, we wanted to do an implementation to see if we can proceed further with this network. So initially we set up all of these things using virtualization technology, VMware, open source, Dockers, etc., and Golang. So we set up all of these in the machines. We have various peers, which these peers basically is for smart contracts. We have multiple snorts, and we had a channel for the blockchain, which the snort they were sending the alerts, and these peers they were getting the informations. So basically, in more details, we have utilized proof of concept and implement a snort CID and a Hyperledger fabric. We have three different snort. As I said, the order organization was initializing the blockchain in the network here. This was also responsible for packing transactions into blocks and distribute them across the peers network. And here, for example, we had the use case that we have a new IDS entry. So if Snort 3 wants to join the channel, Snort 1 and Snort 2 should give approval in order to enter this channel. As I said, it was permission, not permissionless, and that was the idea of this. So after all of this setup, we send malicious traffic to various nodes with some rule sets. So this node 1, 2, 3, they have different rule sets. So we wanted to see if this collaborate thing could work. So it was successfully after we set all of these alerts. For example, if sort 2 didn't have the rule set, all of these attacks and rules were communicated through the snort IDS channel, and all of the snorts they were getting the new rules and new detection from the collaboration between the snort IDS channels. So concluding, let's say, these simple experiments show us that we can use Cyber Fabric uh, for a collaborative intrusion detection systems. It's very good Hyperledger Fabric because it's modular. It has high TPS, transaction per second. The smart contracts is very useful for all of these things that we want to implement. So generally, it's promising, and this is something that we can explore more, adding AI on it with other projects that we have, and see all of this network of intrusion detection system, how they can be behave in order to tackle attacks and stop attacks before reaching other networks. So minimize basically the damage of an attack. That's it from me. If you have any question, you can drop me an email here, and I'm happy to discuss anything with you and collaborate with you.